Testing, testing. Testing, testing. Testing, testing. Okay. Break. Doing. Did I already break it? It looks pretty good there. Welcome to Programming Rainbow. I'm just here live streaming. Let me. All right. Second. Okay. Yeah. Welcome to Programming Rainbow. I've been fighting around with FFmpeg for a long time now. I don't know. Maybe working right now. I'm not a wizard. So I'm just working on some different projects. I'm just doing some coding, so I figured I might as well listen to some music and live stream too. I am going to not be streaming the music, I think. So I'm just gonna kind of have my audio coming through, my computer, not through the stream. If anybody has questions, they can let me know, and I'll probably just be off doing some different projects. I'm working on a beginner's guide for Bash right now. And also, I'm redoing the beginner's guide for C and SDL2 because people keep watching the old version and it's not very good and it's not complete. So I kind of feel like I should do a better version because people are actually using that information. And it's not like wrong, but it's not the way I wish it was. Okay. So I'm going to be working on those. If anybody has any questions, just let me know. So I actually wrote the bash this bash bridge in SDL3, and I had to backport it to SDL2 just so I could get it out the door because the SDL3 wasn't done yet. But I didn't implement being able to change the renderer color. I forgot about it. So I'm just going to implement that real quick. I think it's in here, now, or maybe it's in its own thing. I can't remember. Or it's got to be in here, right? In its own file, isn't it? Yeah, it's in here. Okay. Yeah, it's just a little guy. So I'm just going to implement a way to set the renderer color. So I have a clear and a present. So it'd just be like set color or something like that. I'm just going to dump this in here real quick. Just so I, and then I want to, I've already been setting colors for like text objects and stuff like that, right? So I have reference on that right here. Let's go with the, I know I set the color. It's RGB, whatever. U8. Sure. To U8. Yeah, I called it something like that. Yeah, here I go. I'm setting a color right here. So I basically need to do the same thing for the render. So I'm just going to grab some of this and change it up. So what do we got? Set clear, set color. Yeah. So, P1 is color. So these are going to be like P2, P3. Yeah. Can't do this checking against not being P2 anymore. So here I'm going to do a no P2. Got what I'm doing here is I need one parameter. So when I'm passing a parameter into this parser, I know I have two things. One of them is a what did I call it? An action. So one of them is the action is like the set. The second one I actually don't see it because I'm in the render, but it's going to be the word render. So my first kind of parameter, but I'm calling it action, is going to be set, play, clear, get, something like that. So that's going to be the first thing. I call it action. I pass it in because I actually check something before I pass it in. And because I'm passing it into just the render, I already know it's render. So my second thing was render. Now my third thing I'm actually calling P1, and that is going to be set or clear. So I have, sorry, not set. That's the action. So it's going to be set, render, clear is P1. So P1's clear or present, or it's going to be color down here. So P1 is going to be color. So up here, I'm doing a no 2. So I've already grabbed the P2, but I shouldn't have a P2. So if I'm going set render clear, I should not have anything written after that. That should be the end of the command. So if anything is written after that, I have a problem. So I'm checking this, that there is no P2 on here. And I was just putting it up in the beginning because I only had 2 commands in here, and they only had a P1. They had no P2. But down here, I'm going to need the P2, P3, and P4, but not a P5. So I'm just doing this. I'm just checking it up here. This is kind of just trying to be safe that when whoever's passing in commands, make sure that is in fact the command that they're passing in. So here I'm going to be definitely, the P1. And down here, I'm going to, when I grab all these, I'm going to say if. And I only need to check the last good one and the bad one. I only need to check the bounds if I make sure I have this one but don't have this other one. So I'm going to check. I do have P4, but I don't have P5. So I didn't really need to check it here, but it's fine. So it's going to be P4. Well, in this, I need to be in here for that anyway. P4 and not P5. So if I've reached here, I know that I at least have as many parameters as I want, but they might not necessarily be the parameters I want. So that's kind of the thought process that I'm doing here. If anybody has any questions on that. So what I need to do here is I need to say set render color. So color's P1, and then I need to RGB. I can't set the alpha because it's a render color, but RGB is fine. So I'll do set render color and then an R, a G, and a B. Now the R, the G, and the B need to actually be a uint8. If they're not a uint8, something has gone wrong. So I'm going to check them. So I have this string to uint8, which is basically going to take that and make sure that it is in fact a number, and it falls in between 0 and 255. So I've already got functions to kind of test those for me. So the first one is going to be what, 2, 3, and 4. And so we'll call it red, green, and blue. Yes, that's fine. And now this function, since this function is pretty simple, I'm just going to be using it directly. I think I did it up here. Yeah, I just use the functions directly because they're not too complicated. A more complicated stuff here with text and stuff, I have another file, like say for text, I'm parsing the text, but I don't do the logic of the text here because it's too complicated. So I actually have a text module down here where the logic is, where this is just parsing. But because this is a one-liner and we're not even checking on error on
bash 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 zsh 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 bash zsh
Spam it a lot. So I'm actually looking if it crashes because, oh, what? I didn't use them. Sorry. I still have the hard coded numbers in. Okay. Let's see if we can get it to go out of bounds. Maybe it's not inclusive, so maybe it's going 0 to 255 right now. Yeah, it seems like it would have crashed out by now. Let's try.
SDL 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 SDL
Objects where I just tell it to give it a new string, and if the new string is different than the old string, it regenerates itself and it repositions itself according to how it's been anchored. And the reason why it says 60 FPS right now is because I'm getting exactly 60 FPS. But if I were to change this to like 10,000 or something like that, I think my system can actually do 10,000, but since I'm streaming right now, it probably can't. So let's see here. Where's the 60? Right here. So if we change this, to like, I don't know, 100,000 or something, I could probably do like 5 or 8,000 right now. I don't know. We won't get that solid 60 anymore. Now we're getting, 9,000, something like that. and it's going to drop when I do this because these have to be regenerated every frame. It's taking over at 3000 FPS. Well, these text things are being regenerated every single time it's in a different position. They're being not just redrawn but recreated because it's a text, but it's actually it's a software service that I'm stamping around in a circle, and it still happens fairly fast, but you can see it drop the FPS by like, but in a third. If I turn it that off right there, it's going to jump back up, So it's still way faster than 60 FPS, but you can kind of see that, like, it's kind of a little hacky thing to draw the bubble around it, but that would be bubble.
C
SDL SDL
So these are for bubble text, but the text thing can build normal text to it. They don't need to be bubble. But you need to pass in the renderer, and it's going to hold on to the render itself, and then it's going to have a font size. These are just strings I put in the main.h. So I'm only using one font, but you would pass in a string here to a font. You pass in a size, it's an int for SDL2. Here's an initial string that I'm passing into it, and for the bubble one, radius, not bubble. This one up here would be a non-bubble version, and it's the same text object. So, like, you can turn a normal text object into a bubble if you want to. It doesn't care. But this would be the way if you wanted, you do new text instead, new bubble text, bubble new, you new, render, the font size, initial string, and so that, and color, have those set up. And if you did this, like after radius this, it doesn't Yes. And then we need to draw it. So this is a text. We're not drawing any. Wait. Am I in yellow? I'm doing all this in the wrong spot. Let me grab this and undo whatever changes I've done here. I'm in the wrong file. I need to be in this file. Looks like I was doing something very similar anyway. So it's still called text FPS. It's fine. And then we need to draw it. So we got a sprite. Draw it first so it draws under the sprite. That's the background. So it'll be on top of the back. It's, okay, so that's not where I want it drawn. Oh, because I did center Y instead of So we'll call it what, X shadow. There, still X there. I think I got it all. So this is just gonna not draw anything interesting at first. It's just gonna be a 0. Save it. Done something wrong. So 20 is an invalid ID. Setting color 2020. What did I did? So this is not populated, right? Yeah. Okay. Right here. It's like the variable doesn't exist, so it's just blank. That one. Okay, if I move this guy out of the way. Oh, we're not drawing it right now. So we'll go down. We can draw all of, well, these will be turned on in a different thing. So we'll call them a position toggle or something like that. So I can turn them on and off with like P. So I'll say pause 0, and I'll go up here to right here. The F turns that one on. This one I'll turn it on with P. That's just an associated ray, so I can grab every frame what keys are pressed or held down. So down here, I'm going to add in getting the state of the P key and assign it in the associated ray just so it's easier for me to deal with. Three. So we'll do the same thing with the toggle here. If we did press the P key, we just want to toggle the position from 0 to 1 and 1 to 0. So that will be P there, and this is pause. So what will happen is if this is 1, 1 minus 1 is 0, and if it's 0, 1 minus 0 is 1, right? So it just flips back and forth between 0 and 1 when you press it, which is just like a Boolean on and off. Okay, so done that. So we're going to do basically the same idea right here. I'm just going to copy this. I will put this on pause. This is going to have the X and the Y in it. So we need to get the position of the, what is it, the ZSH bouncing around the screen. We can use that one. So we'll say it's a sprite. We'll say get sprite. We'll just get we can get the position because that'll give us the X and the Y, and that'll work. So I'll say pause. I think that's right. Yeah, it's been a while. Sprite. Yeah, is it just called Sprite? I didn't call it Sprite today. I called it Z. Yeah, that's what I called it. So it's going to get those, and that's going to be in an array. So this is not a get. This is an R. So this will be, X will be the 0, and Y will be the 1 being returned from this. So we can say, we can say set text string, and this one will be text X, both of them, X shadow, and this will be, the string is X, and it can't be reply because it's an array, associated array, so it needs to be array is what arrays come back as, and it's the 0. And this one down here will be the same. This will be 0 as well. And we'll be drawing them same way. So whenever we have the pause toggled on, we'll be getting the X position and drawing it, hopefully. Done this right. I'm going to move this out of the way and put on P. Yeah. Cool. So it's tracking the left side of this ZSH. So it should pop down to 0 in the corner. There it goes. And you can see how the numbers grow to the right. See? So let's put one in the top left-hand corner for the Y position, and we'll see it grow to the left. And we can also put FPS up there, you know, can toggle those on and off, whatever. Okay. So I'm just going to grab all of this X stuff, and it's just going to be Y's. So this is Y, and it's going to be called Y. I won't be able to set the position, but I'm just going to come back to that. I just want to make sure I've changed all the labels. Okay, so the position's no good because we're going for top right, so we're going to set them separately again. So we'll set the Y, which is also top. We could say T, or we could say Y, or we could say top. Whatever you're happy with using, that will work. And so we want the top to be at 10, and the other one on the shadow, we want it to be at 15. And then we're going to have the right side. So when you do this top and a number, it not only sets the top of it, but it also sets the anchor. So like it'll be like when the text is changing size or something like that, it's going to use whatever the anchor was set to. So I don't need to set the anchor because I told the top to be at 10. So it's like, well, since you said top, we're using the top anchor. So when I do this here on the right, which you can say, I could say R or right. Now I can do the width minus 10. Let's do it 15 because we'll do the shadow as minus 10. That'll make more sense because the shadow is going to the right anyway, so we'll do it at 15. And that's not the way you spell. So when we do this here, it's setting the anchor on the right. So the anchor, so we are setting the right side, but now the text, when it grows, it's going to grow left because the anchor is on the right. So on this one here, I'm doing the normal one at 15 because the shadow is going to be at 10. Okay. So that should be, hopefully I didn't make too many mistakes there. I'm sure I did. For this, we only need one draw command, and we already have the information from here. So we just need to do this right here for the Y. This gives us all the information for our position, and this we can use this to draw everything. So here we have our Y, and these are Y shadow. And this one now, the Y is the 1 position. So, oops. Because it returns two numbers, the X and the Y. So this is the X and this is the Y position. And so when we're drawing them, we can just yank this. And we can just change these to Y. It'll just draw them all in one go. And we're toggling the position on and off, so we'll see both of them. Let's come down here, position, and now see, we'll watch how the Y grows and shrinks. The anchor is always here in the top left. That's pretty good, I think. We should do some music on it, maybe. And if we change it back to 60, you'll see it's like it just locks at 60. Let me try to get it right from the beginning. The first second is 0, and then it doesn't do 59 or anything. It's straight locked to 60. Okay, that worked. See if anybody had any questions. No? Anybody over here? No? Okay. So we don't have music up and running. And also this is kind of like, well, it's not too bad. It's like one long thing happening here. I should maybe. So this is the FPS. So if it is playing, then we need to check pause. I'm going to skip that and go to the else. Play music, because we called it music. Yeah, and then let's just got it. So if the music is not even playing, if it's not paused or playing, if it's just nothing's happening, we need to go ahead and start the music playing. But if it is playing, it could be paused. And if if it's not paused, we need to pause it. So now we need to get the state of the paused. Get music. I think that's the command. Reply. So let's see. If the music is paused, we need to resume it. Set music resume, I think that's what I called it. I think that's it, because that follows the else g cmd set music pause, not pause. Hopefully that logic makes sense. I don't know. I actually can't hear it. Let me just see if anybody's asking me. Okay, so me too wanted to say thank you for a great SDL tutorial. Thanks, man. Especially SDL3. Yeah, I know everybody wants the SDL3, and I want to do it too, but I can't do it right now because you can't build the SDL3 audio system yet because SDL3 is still on. The audio requires SDL 3.3. And SDL 3.3 hasn't been released. It doesn't exist yet. So until SDL 3.3 comes out, I can't even compile the source version of the SDL3 mixer because it requires SDL 3.3, and the package is stuck at 224 or something like that, and it requires 230. So I'm kind of stuck in a holding pattern until they sort out their SDL3 stuff. Kind of annoying. Okay, so I can't hear this. I'm gonna undo this real quick just to make sure I can hear it. I don't hear anything. Okay, so pressed M playing music. Did I do that right? Yes. Okay. Let me just make sure I can hear some sound here.
Bash, 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 bash.
Okay, that's very loud bash. And the music, I didn't even try it. All right. It's not playing anything. It's not erroring either. Yeah. Okay, I'm not getting the M here. I didn't add that in, and I didn't add it in here. And so fourth. Okay, now we're going to see if it crashes. Well, that works.
Bash. bash 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 bash.
When it says bash, it's just way too loud. I want to edit though. So I need to go into the code. What do we got here?
Bash bash
Dang, that's
bash
loud.
bash bash bash
That's probably good.
bash.
Do I need to just save it? I can't remember. Save project? No. Just export it back to where it was in that folder. Yeah. Let's open up the other one.
Bash.
Oh, that's too loud. Come on, select. Oh, I'm really good at this. So let's see here. I think I used this one. What? Did I not?
Bash.
Why am I not on the pointer? Thinks I want to. There we go. There we go.
Bash bash bash.
Good enough. I don't want it to be so loud. So export. Oh, bash, yes.
ZSH.
Oh.
Bash 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 bash. Bash. ZSH. 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 Bash 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 ZSH. ZSH.
If anybody was wondering what it sounds like, hopefully it's not too loud. I try to bring the volume down quite a bit. But basically, every time ZSH bounces off the wall, it says ZSH. There you go. And whenever I press space, it changes the background color and it says bash. Okay, so, and then we can press M to start playing the music, or pause the music, or resume, pause, resume. Yeah, you get the idea. And it's that Moog GNU, you know, this free software song by Richard Stallman. And there's the icon of the bash in the top left-hand corner. We set this so.
ZSH.
So this is all, yeah. Call these global variables. These is, I'm sure I'm going to spell this wrong. Associated array. I'm sure. Okay, we start the game, we set the title, we set the size, we set the icon, we set the background. Right there, I'm just putting that one time. We're creating a rect for this background. I did that. That's all the image one. Now we're switching over to sprite world. Load an image as a sprite. We're doing that several times here. Now we're doing the fonts or the text. So I'll say I'm setting anchor. Or and we're doing that over and over again there. Yeah, over and over again. So where are we loading the sound? We're loading the sounds. So here we're loading music. Loading sound effect. Loading music. Optional. B. I can't spell. Option. Set. Set. So that is turned on. Now we have all this stuff in here. This is getting all the key pressed. play, start, play music, or play or pause music. This is moving the. Oh, we can use them the ASWD or the arrow keys. So moving the layers a. Oh, hopefully the 3.3 audio, yeah, will come out fairly soon. It's not the audio component that's not done. I mean, like I could build it in the. Let me show you what I'm talking about. If you don't know what I'm talking about here, so if we go to Arch Linux, by the way, and we say SDL3. So we have a package here, right? SDL3. SDL3 is not by itself a working package. So imagine if you have a car, SDL3 is like the frame of the car. It's not a car, it's a frame. Yeah, it is a library in itself, but it's like in specific cases it can be used by itself, but you could use like a car frame by itself too, I guess, if you wanted to. But really you need the whole car. So you need wheels and you need an engine and you need doors and stuff like that, windshield, right? So for SDL you need the TTF, you need the mixer, you need image loading, things like that. Now technically you don't have to have those. Again, you can have a car that doesn't have an engine in it and you just roll it down a hill technically, but realistically you need the whole thing. So this is 2.224, and this is the latest version. They're not behind or anything like that. There's not a secret version of SDL out. So 2.224, this is the actual official package, right? And even if you're using SDL2, you're actually still using this package because SDL2 Compat requires this package right here. So if you're using SDL2, you're actually still using SDL3 under the hood. So if you're in Arch Linux, that's pretty much bleeding edge on the Linux side. You are using SDL3, which is version 3.2.24. And that is the latest version. Now you're saying, oh, well, I said that, this is part of what you need, but this is not the whole story, right? So the rest of the whole story is not here. You in packages, you're not going to find the SDL3 components, right? And that's not a big deal. Nobody's worried about I'm not going to shy away from looking at the AUR. You shouldn't use the AUR as a daily driver, but it's not such a big deal. We know that they're still working on this. They should not claim that SDL3 is done or ready or complete, like they have been. They have been saying this for like a year now. It's not. SDL3 is not ready. It is not complete. It is buggy and also unfinished. But so we have SDL3. So where do we get the rest of SDL3? We go to the AUR and then we look up SDL3. So the TTF, somebody has graciously made this package, and that's great. And there's an image package, and that's great. But when you get down to the mixer package right here, now we have a problem. Because these packages here will compile, but this package will not compile. Okay, this package requires SDL3 3.30. Okay, so that version does not exist. There is no such thing as SDL3 3.3. And again, this is saying to even do the alpha or beta version of this mixer package, you need SDL 3.3. So that means SDL 3.3 is the alpha version of SDL. It's not a stable version. It's not done yet. So when you try to build this, it will not compile. It's not, So again, I could probably pull all the source down, but I'm not going to do that. And I'm not going to expect other people to do that. So right now, SDL is in a frozen state of not being done, where they're claiming it's done. They have roped in Arch Linux into using SDL3 as an SDL2 backend. When it's not ready, and they are don't have the packages ready. These packages that are not ready need a future version. How do they need a future version of something that's ready and stable? So it's like when we get to SDL 3.3, we're kind of in alpha land. We're going to have maybe something that works, but it's definitely going to be buggy and broken, but maybe it'll actually compile now. Yeah, so this is like, you can't do anything with this, you know, like, let's see if I have it. What's it called? Mix or this one, right? Let's just get rid of it. CD. Okay. So let me grab the, where is it? And then this is the only mixer one here, right? Yeah, it is the only mixer one. So I'm just going to grab this guy. Okay. Doing some stuff. And what do we need? We need SDL 3.3. There is no SDL 3.3. SDL 3.224 is the latest version of SDL. There is no 3.3. It doesn't exist. So this is just nonsense. It's, you know, you imagine you go to the dealership and you ask for a car and they give you a frame of a car and they say, well, you're going to have to go across the street to the people who bootleg some tires. They're not done yet. You can put the tires on it and you can get a windshield, but the engine doesn't fit in this car. The engine's for a car that's coming out next year. But go ahead, this car's done. Go drive this car away. It doesn't have an engine in it yet, but and it doesn't fit with this car. You're going to need a future car. But so this is nonsense. So again, I could sit there and compile this whole thing, compile SDL3 from source and everything else, but it's just like, why am I doing that? Who's gonna benefit from that? It's the normal package is gonna come out and it's gonna break some other stuff on my system, you know, like it's, you know, potentially can break everything that's SDL3 and SDL2 on my system. And I don't want to mess around with that. And I'm just guessing it's going to have a nightmare of other AUR dependencies that are going to be required because just to build the main package, you know, it's going to require these other things too, probably. And I'm going to expect other people to watch my videos and then also go down this like nightmare hole. Like, how do I get this on my system? It's not done yet. It's in the future. You know, this version is in the future. It's not ready. And also like it's been buggy, so buggy. Like I put in bug reports. I asked them to roll back the package, the SDL2 package and SDL3, and the guy that was a maintainer trapping. This not track, but if the server is still running, send it to. Then I'm going to get rid of closing those pipes, moving the files that I created in the template, whatever. So the traps, if it receives a signal from the thing that's a negative, it'll shut it down with a one. If it's not negative, shut it down with 0. And then I'm defining the command right here. So this is the command that does all the hard work. This is that sends all the messages to the server and receives messages from the server. So if I'm just sending a message to the server and I don't want anything back, I just echo it. It's a little bit faster than the printf command, so I echo it, whatever I passed in as the first parameter, to file descriptor 3. And if it errors, I'm trying to shut down if it errors, but I'm not sure if this actually works, this logical OR here. But if I'm using get or new, I'm going to receive back something that's going to be populated in applied global variable. So I have a case on it. So if it began with a get or a new, no, I need something. If I do a new thing, I have a D for what I've created on the server. And if I do a get, I have a kind of number coming. So I know one thing is coming back. Do a get or a new. So, and this is blocking. I don't want to do this. Meaning, so I'm doing a read on file descriptor 4. So sending out on 3 and read 4, and it's being stored in reply. Now, if I'm using array free, both of those are going to return back array. Now, I didn't show any free because you don't need to use free, but if you did want to use free, that is a fully functional thing where you can free IDs of things, reallocate new things. Mostly, but under the hood, it is doing. But anyway, so these two are returning an array, so I'm going to read back. But this is not a single thing. It's something I want to be array. It actually comes back as a base string. So I want it to be an array, but because I'm trying to make it DSA2, do it instead of using my array. But it's this thing without it. I guess it works for both bash. So this is the function that defined. So when we go into this beginner's guide, if I were to get rid of this script, you don't need all
bash ZSH bash ZSH ZSH bash ZSH ZSH
Here, we're setting up, and this ends up socket almost. Let's look at socket speed. It's not quite. So
ZSH
we were getting 16 before. Now we're getting
ZSH bash
Still really
bash ZSH
a little bit. And the standard, it's like crap. It's a thing I couldn't even. So same stuff going on here. Set the server up, making sure the server's compiled. And now we're doing a similar kind of co-process, but instead I'm actually running not a socket as a co-process, but I'm running the server as a co-process, capturing its in out and mapping it to file descriptor 3 and 4. So mapping its standard in and standard out to file descriptor 3 and 4. And then so down here it looks the same again. They don't all look the same. But socket, okay. So what happens when we get to like share? Starts to get a little bit weird. Let me show you the client one first, because the client one has a little tiny client that like there's another source code you have to compile, and this does not work on it. The shared one doesn't work on it. Shared, it's because it's using shared. But you need the little client program compiled as well, so it's playing about both of those. And now we need a lock file and a data file. So we're going to touch these two files, and we're going to use file descriptor 4 in read write mode. And I think this is yeah, it's in dev shim, shared memory or whatever. That's where we're doing this at. So it's like making a file, but this file is in RAM. It's not a disk file, it's in RAM. But the problem is that you have no way to communicate. Like you don't know when something can be read to or written from or whatever. It's not synchronous. It's not. The pipe is blocking, and so is the socket. So like it handles communication. Whereas the pipe, it's just like you just put whatever stuff in a file or in a memory location. Something else may be reading it while you're writing to it. So what I did is I put two files, and I used one of them with just 1 byte as the lock byte. So it knows if it can write to it or read from it, or if somebody else should read from it. So that's what I did. Let me just see if anybody's asking crazy questions. Lots of questions. Okay. Multimedia scripting this neat concept. I need to show these videos. Or like collection of components, but yeah, you need those. My mic audio is not working. Let me double check it. Yeah, you need those. Testing. My mic audio is not working. Let me double check it. Testing? Yeah, you need those. Testing. I'm not sure. I always have problems with the streaming thing. It says it's working. I don't know. Let's see. So the shared one. The shared one gets a little bit crazy because imagine this. Imagine I have like these two lines here, right? Oops. Where did that go? I don't know what I was doing. Oh, this is the client one. Where's the shared? It is the same. Okay, so anyway, the client and the shared are partially the same. So imagine I have this like two lines, right? One is a data line, and one is the lock, right? So if I'm writing to data from Bash, my server is actually spinning on it, reading it, right? So if I send a little bit of information, a little bit more, my server can be like, oh, I got it. It never knows when it should be, and it might be trying to write to it too at the exact same time. So what I do is I set it to, if lock, I only ever change 1 byte in lock, and if it's set to 0, I actually use hexadecimal 0 and 1 too. But anyway, if it's set to 0, the bash can write to it, and the C server is not doing anything. It just looks at lock. It says lock is when lock is 1, C server can look at it, but until lock is 1, C server can't look at it. So C server just keeps looking at lock. Says, is it 1? Is it 1? Is it 1? No, it's 0. So while it's 0, I can write and I can send in my new bright, whatever, so on and so forth. I can send my data in. Once I'm done writing it badly, then I switch this to 1. The second I switch it to 1, my C server is spinning in a loop, basically. It says, oh, pull that in. So it reads this in, and it says, okay, and you need and it creates that instance of the sprite, and it says, now you need an ID back. So it writes the ID back. So it says, the ID is 2 or something like that, right? The whole time this lock is sitting at 1. So while the lock is at 1, bash, or however am I doing it, is saying it's not my turn. It's not my turn, right? It just keeps looking at the same thing. It's the one's not my turn. So this thing says, I'm sending you back the ID. It's at 2, and now I'm going to set this lock to 2. Once the lock gets set to 2, bash says, my turn to read. It says, I get the 2, right? And now the 2, I'm going to set the lock to 0, and the 0 tells bash that bash can now write to it. So it just does this over and over again. So what happens on the client is I actually have I spin up a little C program as a client. I pass it in I pass into it the parameters as an argument, and then it connects to the shared memory. It does the same thing with the lock, and it sends that information. The server sends the information back to the little client. The little client then echoes it out, or printf or whatever, sends it out on standard out and shuts down. This is the way that the AI told me was the very fastest way to communicate, the fastest possible way to communicate, period, between two processes. Inter-process communication is through shared memory, and all you need to do is just use a little client program, okay? Hold on one second. So this is the premier way. This is faster than sockets. This is faster than pipe. This is the fastest way you could possibly ever do this. You just need to use shared memory. And if you're talking from bash to a C server, you just need to use a little client app, okay? So let me just show you how fast this client app is. So here we're setting up the shared memory, and what I'm doing here is I'm initially setting it with a hex byte 1 to be 1, so that the server, so that not the server, so bash knows not to write. It's like not your turn yet. When the C server gets up and running, it's going to clear this to 0, and then the shell is going to know it's my turn to write. So it's just like while it's getting up and running, I set it to state to 1, meaning it's like blocking until the C server gets up and running and it clears it. So this is just making sure the C server is not running, shutting it down first if it was already running. Now we're starting it up in shared mode. This is making sure it did get started. Here I'm setting the quit function, and it looks somewhat the same, but it's not the same. We're doing this funny thing here. We're basically capturing the output, and this is slow. This is either a subshell or something akin to a subshell. I'm not actually an expert in this, but it's slow. And so we're doing the same thing. We're doing the command. If it's new or get, if it's get or new, we need an answer back. If it's this one, we need an array answer back. And so this is, let me show you how slow this is. So the other one we're getting was it 1300 to 1600, depending if we're doing pipe, standard in and out, or socket. And those are all blocking too. The pipe is blocking, so you're losing time with blocking, and socket and everything else. So this is the client one. And it's going to say I haven't compiled the client. Oh, it didn't. Okay. So let's check that one and that. And we're getting 56 frames a second. Okay. Before it was 16 to 1300. Now we're getting 56. So this is really bad, because you think, well, you can play a game at 59, 57 frames a second. Yes, you can. But this isn't a game. This is a little tiny demo app. A game is going to have way more send and receives. So when you go to try to play something that is more complicated, it drops down to like 1 frame a second. It depends on how many send and receives, how much communication you have. It's you want that headroom. And let me show you another thing so you get an idea of what I'm talking about. So text, this was the text. And the fastest way we can get this running here is about 80. And where I'm running 200 pieces of text. And now if I try to change the color of them and the text information on all 200, every single frame, I'm getting 46 FPS. If I try spinning them all and with their own spin, on all 200 of these, I'm getting 42. So I'm doing a lot of stuff here. I'm doing bounds checking. They're bouncing off the wall and everything else, and they know their position, and they're setting their color and their number based on their position. So I'm doing a lot of compute here. But if I were to do this in, say, the std in out, done. Okay, so if I do this with, I think I'm on std in out, and we spin it and we look at the FPS, I'm getting around 40. Okay, so we do a socket, we'll get a little less probably, or around the same, depends. 38, 40, not too bad. Okay, so we have shared memory. I haven't showed you shared memory yet, but if we do shared memory, we spin them, we're down here, and if I can turn on FPS, we're getting 10, okay? But let's do client, and I have this feeling client's going to crash because it's so slow. Something will go so far beyond off the screen that the numbers will not. So let's try client, and let's spin it, put on FPS. I didn't even take my input. Come on. There we go. Oop. And it crashed because because things are moving off the screen so far. I'm trying to use the numbers of where the positions are to modulate to do a modulus on the for the color, right? And if it goes on a negative number too much, it's just gonna, and that's what's happening. So like it would drop down to like 1 frame a second. So like, yeah. So just with the was it yellow snow? If we do client, just this one, it gets only 21 FPS. But here we're getting 700. So I could make this game more complicated, 10 times more complicated, and still get good frame rate. This is still a simple game. I only got like 15 objects moving, 16. I'm checking bounds on 16 objects. It's no big deal, really. I'm drawing a couple things, So the performance is important, but according to the AI, the client version, the one that gets 10 to 20 FPS, is the fastest, definitely the fastest thing you could ever do. And it's not. It's the pipe. The pipe is fast. Like technically the shared memory is faster if there was some way you could talk from bash to the shared memory. But the problem is you can't. However, I do have a shared memory version, so I'll show you that one. I hobbled this together. So the client is doing shared memory, but the spinning up of the client and the shutting down of the client is 100 times slower than the other methods, just for communication purposes. So here's instead of me using a client, here's me doing the shared memory directly from bash. So this time we don't need the client program, we only need the server. We do need the 2 shared memory spots, the lock and the data. It happens the same. We're making sure the server is compiled. We're touching those files if they don't exist. We're setting the lock to 1. So this is the way we're going to be communicating. So we have to open the shared memory in read and write mode, not just write mode, because it'll change the size of it and then it'll crash the C server. So it does have to be read-write mode. That's why you have these 2 different things here. That's read-write mode. So the server is opening up the shared memory and I'm opening the same shared memory up. And so I'm opening file descriptor 4 up as the lock file in read-write mode and setting to hexadecimal 1, which is like a 1, like one bit was turned on or whatever. And I'm printing it to file descriptor 4, but then I need to close it. I can't leave it open because it doesn't rewind. There's no way in bash for me to rewind unless somebody else knows. So what I have to do is I have to close it every time, which probably slows me down a lot. But we're making sure the server's already running. Kill it. Yeah. Making sure the server is not running yet. And because we don't want a stale old version of the server running. Now we're going to start the server up in shared mode, make sure it is running, making our quit command. And this is the way we communicate. So we're checking the lock to see if we're at state 0 to talk on it. Yeah. So here we're basically getting status from lock and then closing it right away. Now we're checking that lock to see if it is in fact 0. If it's not 0, we're looping right here. We're just looping in a circle until it is 0. If it is 0, now we can talk. So when this function gets called, it's just going to sit here and loop here until it's allowed to talk, until it gets its turn. Once it can talk, we're using file descriptor 3, which is the data one. And we're going to send the information with a null terminator at the end of it to file descriptor 3, and then we need to close it. And now we need to reconnect to the lock one and read the lock byte. And we close that as well. Because, we're setting the lock byte. We're setting the lock byte to 1. That means the data has been written now, and now the server knows it's turn to read. Now, if we needed an answer back from the get or new or array or free, we need to now start looking at the lock file again. And if it's 2, we can do something. If it's not 2, we're looping until it is 2. So that means the server sent something back. And then we're going to get that data back, and then set the lock now to 0. So it's all done. That whole round trip is done. If it's an array, it's very much the same thing happening, but we're doing it as the array answer back instead of a single thing. So this looks way more complicated, and all of it's happening in bash, but this is like 10 or 15 times faster than that client app doing the same thing. This is so much faster, but this is still slower than, like if we did the yellow snow and pipe is 800 thereabouts. Socket is going to be a bit slower, 650, 700. And then shared, me hand rolling it from bash, it's like 150. It's quite a bit slower, but still cooking. And then the client, this is shared memory as well. The server reads this exact same, but there's a client tap on this one. It's terrible. It's very slow. So yeah, that was a lot of information about that, but drop down nothing through currently. That's weird. Let me check it again to see if drop down still there. Okay. Maybe I had it muted and I didn't realize it or something. But yeah, so yeah, I did all these different, I ended up with 5 different backends. It's doing way too much stuff. But yeah, so basically you don't need this right here, but this server right here, once that's it, you compile that and you just choose one of these backends to use. And I just put some example stuff. So this example folder is just examples to run. But you just need to source one of these, which I recommend Pipe. Pipe seems to be the fastest and stable working one. I actually haven't had any of them fail on me. Once I've got them working, they've all worked the way they are expected to work. None of them have problems communicating. I was really surprised the standard in-out worked the way it does. But yeah. But this is all examples. Some of them are just tests I was doing just to see how things were working, see how quick I can make things happen, how many, like there's a sprite one where I do 400 sprites on the screen. And it's, let's see, we got FPS. Not going to tell me FPS, is it? It's just too slow here on the client one. Let's see if it works in shared. So I'm getting 15 here. I would probably be getting like 2 or 4 or something, 20 FPS, right? This is 400 sprites, and I can spin them. But if we go to socket, now we can get like 45 FPS. We can make them bigger, and